Hey everyone, welcome to the lecture series of Elementary Classical Mechanics, where we embark our journey from basic to advanced physics. This is lecture number 7, part 1 on Introduction to Scalars and Vectors, in which I will explain the intuition of scalar and vectors and other stuff regarding that. This is important because you will soon deal with two-dimensional motion, then Newton's laws of motion, and vectors and scalars plays a major role in that. Anyways, in this lecture, we are going to learn about what are vector, intuition of vectors in the form of demo, and scalars, representation of vectors, and components of vectors. So let's get going. Vectors are the physical quantities which has both magnitude and direction. Magnitude is just the strength or length of the bodies or particle, which are just numbers. And direction is just, as the name suggests, is which way the body moves. Example of vector quantities are displacement, velocity, acceleration, as we have saw in our previous lecture in classical mechanics. Alright, I am pushing the cylinder in the forward direction which has covered a certain distance, then this is displacement. With distance as magnitude and direction it has moved is forward or in a positive x direction. You have to have fixed reference. Now I take back the cylinder, then it is moving in a negative direction with distance as magnitude. So we get the displacement as negative of this is negative x direction. I can move that cylinder up of y positive direction and not downward cause I am constrained to the table. But if I was able to move, then that will be negative y direction. The movement of cylinder is defined in terms of both magnitude and direction is a vector quantity. If we can apply the rate at which the cylinder moves, then it will be the velocity and so on. Scalar is just the magnitude of the quantity. There are some physical quantities which do not have directions, such as temperature, distance, current, speed, mass, and time. Now, just for brainstorm, tell me why temperature is a scalar quantity even though it has both negative and positive sign. Please give your response in the comment box. The mathematics of scalar quantities is done as simple algebra. But for vectors, the algebra is different, and in the next lecture I will take that. Now let us understand how vectors are represented. As I demonstrated and told earlier that the vectors are the quantities consist of both magnitude and direction. But how it is represented? The vector can be recognized when we see the bold letter or arrow over the head. I prefer the arrow on the head of a letter. This vector is called as vector A. But what that vector equivalent to? That is the important thing to understand. So let us consider a vector A which is represented as magnitude of that vector mod of A, and the direction of a body moving is A cap. Yes, the mod sign alongside the letter will make the vector as magnitude, and the letter beside it is a direction letter with the cap on it. Now that letter is directed to any one of the x, y and z direction. So if the body is moving in x direction, then it is represented as x cap or I cap. For y direction, y cap or j cap. And for z direction, z cap or k cap. This just shows that in which direction the body is moving. And the magnitude will tell us how much it will be moving. What happens if some particle moves in the x and y plane instead of just moving on a single direction, or in between the x, y and z direction? How the vector is represented, right? These questions are important to answer. The answer is components of vectors. So if a vector A is moving along the x and y plane, then this vector is represented as vector A equals to A sub x, x cap plus A sub y, y cap. Remember, this cap is important, otherwise it is just another letter. And it is important to note that this is two-dimensional form. Ax and ay are the x and y components, which are the magnitude along that particular x and y direction only. These two combined components will give us magnitude of the vector as shown here. Mod of a equals to the square root of a sub x squared plus a sub y squared. Just when you square or apply the dot product to itself of vector, you will get magnitude. These types of concept will be covered in the next lecture on mathematics of vectors. We can represent the three-dimensional vector as vector A equals to a sub x, x cap, plus a sub y, y cap, plus a sub z, z cap. And the magnitude of A is square root of ax squared plus ay squared plus az squared. For example, for the one-dimensional, velocity is represented as v equals to mod of v x cap or y cap or z cap. For two-dimensional, the vector is represented as v equals to v sub x, x cap plus v sub y, y cap or any of the following cases, depending upon the problem of the situation. Similarly, the acceleration is also represented this way. Hey, you made through the video. Well, I'm a bit of slow talker. Anyways, if you are interested to learn with me from basic to advanced physics, please subscribe the channel. That will definitely encourage me to work harder and better for more quality lectures. If you like the video, you can click the like button or you can leave it. Alright, good luck and until next time, stay tuned.